Hi guys, this is section 1.1 enrichment. We're talking about rates of change here, which is just a fancy way of saying kind of like slope for a line. So what do you think the slope is for number 1? Hopefully you recognize it should be 3. So slope is an average rate of change, same thing, except for when we're talking about a quadratic function, we don't call it slope anymore. We call it average rate of change. So they give us this expression up here to represent it. So what we need to find is f of 8 minus f of 3. This is average rate of change. And that's all going to be divided by 8 minus 3. So let's find f of 8. That would be 3 times 8 minus 4, which is 24 minus 4, which is 20. And then f of 3 would be 3 times 3 minus 4, which is 9 minus 4, which is 5. So my change from 20 to 5 is 3. My average rate of change is taking that and dividing it by the number of terms in between 3 and 8. So this we said the change between 20 and 5 is not 3 mishears, the change is 15. In other words, to go from 20 to 5, we've got 15 units in between us. So f of 8, which is 20, minus f of 3 is 5, all over 8 minus 3. 20 minus 5 is 15, 8 minus 3 is 5. My change is 15. The average over the interval that we're taking the rate of change is going to be 5. So 15 divided by 5 would be 3. Let's look at it when we've got a quadratic. Here we're going from 2 to 4. So f of 2 is going to be 2 squared plus 6 times 2 minus 10. That'd be 4 plus 12 minus 10. 4 plus 12 is 16 minus 10 is 6. And then f of 4 is 4 squared plus 6 times 4 minus 10. That's 16 plus 24, which is 40, minus 10 would be 30. So again, my change from 30 to 6 is 24. That's my average rate of change. My average rate of change for this one is going to be that 30 minus 6, but this time over 4 minus 2. Change in x is 4 minus 2. So 30 minus 6 is 24, like we said, over a 2-unit interval. My average rate of change would be 12. All right, for the next problem, it says the average rate of change of a function f of x over an interval is the amount the function changes per unit. Change in x, as shown in the figure to the right. The average rate of change between x equals a and x equals b represents the slope of the line passing through the 2 points on the graph of f with abscisses? I've never heard of this word before. A and b. That's pretty interesting. I'll have to look that one up. There's your SAT word for the day. All right, which is greater, the average rate of change of x squared between 0 and 1 or between 4 and 5? So if we look between 0 and 1, we have f of 1 minus f of 0, 1 minus 0. So if we plug in 1 here for x, it would be 1 squared, which is 1. If we plug in 0 squared, we get 0. So that's just 1 over 1. So the average rate of change between 0 and 1 is 1. So let's do the same thing between 5 and 4. So 5 squared would be 25, minus f of 4 is 4 squared, which is 16, all over 5 minus 4, which is 1. 25 minus 16 would be 9. So that makes sense if you think about the graph. My rate of change between here and here is far less than between 4 and 9, which is probably something way up there, because it's squares, right? All right. Which of these functions has the greatest average rate of change? between 2 and 3? Is it x, x squared, x cubed? Take a second to think about it. And what do you think it would be? Hopefully you recognize it's probably going to be x cubed because that changes the most over time. So f of 3 minus f of 2, 3 minus 2. So we're talking about this function here. So 3, f of 3 would be 3, f of 2 would be 2 over 3 minus 2. That rate of change is just going to be 1. For x squared, what's our rate of change? We got f of 3 minus f of 2 over 3 minus 2. So f of 3 would be 3 squared, which is 9, minus 2 squared, which is 4, over 1, so that's 5. And then finally for x cubed, f of 3 minus f of 2 is going to be 3 cubed, which is 27, minus 2 cubed, which is 8. 27 minus 8 would be 19. So winner, chicken dinner, we got h of x equals x cubed. That has the greatest average rate of change, at least between 2 and 3. All right, find the average rate of change for the function f of x equals x squared in each interval. So we're still going with the same motions here. So f of 1.1 minus f of 1 all over 1.1 minus 1. So this would be 1.1 squared minus, where's my parentheses? 1 squared all over 1.1 minus 1 would just be 0.1. I have to break out my calculator for this one. Figure out what is 1.1 squared. And that would be 1.21 minus 1 squared, which is 1, all over 0.1. And then 1.21 minus 1 would be 0.21 divided by 0.1. And that's 2.1. So 2.1 for A. All right, I'm going to erase just a little bit so we have some more room here. Hopefully you got that down. For this one, we got f of 1.01 minus f of 1 all over 1.01 minus 1. F of 1.01 would be 1.01 squared. That's 1.0201. I did that in the calculator, not my head, so don't think I'm all fancy. 1.01 minus 1 is just 0.01. And so I've got 0.0201 divided by 0.01. And that'd be 102.01. And then again, erasing some room, we've got f of 1.001 minus f of 1, all of 1.001 minus 1. 1.001 squared is 1.002 minus 1 squared, all over 0.001. So that'd be 0.002 divided by 0.001, and we get 2. I feel like I did something wrong there. Nope, 2.001. Got it. All right, what does the average rate of change appear to be approaching as the value of b gets closer and closer to 1? So I'm doing this after, or making this video right after we did limits. So hopefully you're seeing our values here went from 2.1 to 2.01 to finally 2.001. So we can talk about it in terms of limit. It's getting closer and closer to the value of 2. So I'm running out of time here. Number 6 will be on the next video.